Welcome everyone. Welcome to Series 10, Space4Women Show, satellite data usage for water monitoring and management in Africa. This topic is dear to my heart. I know I shared this in Series 1. We all had the opportunity to share our personal story. I was born in a developing country and did not have access to clean water. So my mother bent over and gave me puddle water because she did not have enough breast milk to feed me. So this is it's a big honor and privilege to be in the situation to give back to developing countries. We have very special guests today. We have Miss Anne, excuse me, I'm just losing Zoom here, from Uganda. Bianca, can you read her name, please? I don't have access to this now.
Oh yeah, yes. So Anne,
I have it. Excuse me. It's Miss Anne Serunjogi Namakula from Uganda. So she's going to share with us first hand the actual issues in Uganda. We also have my dear friend Basuti Gerty Bolo. She's a space scientist and chair education technologies in Africa University. And she's a UNOOSA Space4Women mentor. And we also have my friend from the International Space University, Miracle Israel Nazarious. He's an aerospace engineer and PhD candidate in space instrumentation. So in today's show, you will learn what the state-of-the-art systems to water management in Africa is, how remote sensing technologies boost local water management and economic growth, and how can African institutions and private companies increase their access to satellite data and Earth observation programs. So welcome to our speakers today and our mentors. Thank you everyone for joining Space4Women Show today. Bianca is our moderator today.
hello everyone.
Are you frozen, Bianca?
I can see you frozen. I don't know what's going on, but yeah. I'm here. So yeah, thank you everyone for being with us today. It is, as Ian said, it is first of all an honor to speak about such an issue that can be solved and can be tackled with space technologies. So the first, starting with Anne, actually we met Anne via LinkedIn, and the way we connected was exactly about the usage of satellites, data and telecommunications to use internet and education in developing countries. The first question to you, because you are an expert in water utilities supplies in Uganda and Africa areas, but also a certified health and safety practitioner. So the first question would be, what are the systems that at the moment they are used in your geographical area to keep monitoring and the water supplies, and also managing as well the water supply, not only in your local area, but let's say around Africa? What would be the state of the art?
Thank you, Bianca. Can you hear me?
Yeah, we can hear you well.
Great. Good evening, everyone. It's evening here in Kampala, Uganda. I am Anne, as introduced. I'm a water specialist, and most of the systems being used are at two levels: the level of service, but also the level of the resource. Water is a resource that we should monitor and exploit sustainably. So some of the systems we use are still very localized. They are manual systems, and these include wells, groundwater wells, and for open resources like lakes and rivers, they are actually some sort of like a ruler method. So we have some manual methods that are being used and monitored all over the country. The country has a Directorate of Water Resources Management, which is an institution at the central government level. And here they are in charge of making sure the water resources are exploited sustainably, but also in a way that brings economic development to the people. So they issue exploitation permits, and at the same time are in charge of keeping the data that is got from the manual monitoring methods. Then on the level of service, this here I mean utilities, we have utilities recording the water they are getting from rivers or from the ground, and this is recorded by use of bulk meters. And at the same time, the water consumed is also recorded. Most homes have individual meters that are read on a monthly basis. This is happening for the population that has piped water. The population that does not have piped water is actually the bigger one. These use mainly shallow wells or deep boreholes or hand pumps. And for these, the monitoring of their resource is very limited. I thank you, Bianca.
Thanks to you and for your introduction. So now I would like to go back to Basuti, because as we know, you have experience in the usage of satellite for monitoring water supplies. So what will be, from your perspective, the effect and also the influence that the space technologies has had and can have, helping the population to get monitored water and also clean water in areas that at the moment are not reached?
Thank you. Good evening. My name is Basuti Bolo. I'm from Botswana, but I'm working at Africa University as a Shared Educational Technologies, a space scientist, application scientist. So Africa, like any other continent, we do have challenges of water resource management. We have a problem of polluted water, salty water, and water scarcity. So the solution to that is space science technology applications can help to monitor water resources. Like we can use satellite data that can map the land use, like what is happening in area like land use, so that we map our water resources. So by mapping water resources, we can easily see what is happening in which area in Africa, like mapping our resources, like lakes, oceans, rivers, and also we can also use satellite data to map like the polluted water to see areas of potential, the areas that can have waterborne diseases, potential areas, and also using some satellite data that has high resolution data to monitor small water bodies. So like, it's not that we can only use satellite data, you know, for you to monitor resources, the resources that are different in sizes. So there are the smallest resources where other countries have small water resources, water resources. So if the country has smallest water bodies, so that's where now we need very high data. Like in Africa, we don't have satellites to monitor our resources, but that provide precise, very high resolution. So now what we can introduce, we can also introduce the use of drones. Drones technology can also assist us by providing very high quality data to monitor our resources from the smallest body to the largest. Thank you. I'll keep on adding more information on that. Thank you very much.
Thank you, Bianca. I have a baby. She may be a little irritated from the day, but please bear with me. I'm going to share with you a way in which we are monitoring water supply services. This is a case for Uganda, and this particular case is from the northern part of Uganda. On your left, upper left, that is a map of Uganda, and those are administrative districts of Uganda. And the darker blues are areas where access to water is in a shape that needs to be improved. So we are women, most of us here are women, and you know, traditionally, especially here in Africa, the role of food security, but also water security in a home largely lies on a woman. That is why my first page has that lady. Let's go to the next slide. So here we were doing water asset management, and on your right you see a map that is a geographical area of a certain town in northern Uganda. We had taken interest in the infrastructure because I'm a civil engineer, so our target was really looking at the network. Where is the network? The network of pipes that deliver water to people. We looked at the water sources. Where does the water come from? We also looked at the water storage. How is the water stored? So when we were analyzing this, when we were looking at this, this town, we went ahead to study the network, to look at things like constriction, which areas are having very good supply. And this was in our offices. We were using some software to analyze this. However, time had been put in to collect this data using a GPS and to map it so that we can understand how the people are distributed and how the network itself is distributed among them. Next page. But as we were doing the actual groundwork, the fieldwork collection of data, we came across dry taps. So while we're engineers and we're interested in how the pipes are distributed, it was more important to listen to the people so that we know how they feel about the service that is being delivered to them. Next slide. So I've already explained that majority of the Ugandans live in rural areas, and that is about 80% of the population. And in these rural areas, the best way to receive information is by radio, and of late, a mobile phone. So we had to combine and get consumer feedback from the population without doing door-to-door visits like we had done to collect the meter points. If you remember the red dots in my previous slide, all those are consumer points that are showing meters. But you remember, they are consumers that share a water point. That means the homes represented by the water dots are more in terms of the consumers. So we had to devise a means of listening from the consumers. So we sat with the stakeholders to identify and formulate questions that we think are the most important to the customer. We broadcasted those questions by radio, and we sent the consumers a code that they should use to send in a free SMS, and that data was relayed back instantly and were able to analyze it. Next slide, please. So here you see the different partners we are working with, but also the results. There were so many questions, but you can see we had, for example, how can your water supply be improved? There were different options given and people were able to answer. And then for the second question, you see, we asked, where do you get your water for domestic use? And you see that majority of the people get it from a hand pump or borehole, as I had earlier on mentioned in the introduction. So with this tool, which is digital, the mobile phone is digital, and then the radio is a conservative method, we were able to get consumer feedback about the water services they are receiving. Next slide, please. So in terms of technology, there are very many areas that the water services can actually leverage technology. And there I've listed some of them. We have the customer engagement, we have fintech, we have space that we are talking about today, we have smart metering, leakage detection, the catchment management. Sorry, that is about the water resources itself, and of course, knowledge management. When all this information is gathered, we need to keep it well and analyze it well. That is my submission. And lastly, I intend to actually hold a summit on this, and if there are people willing to collaborate, I'll be glad. Yeah, thank you, Bianca. That is my end of the presentation.
Thank you very much, and it was a fantastic presentation, and praise to you for being so collected and focused on giving the presentation. It was great, really fantastic. So looking at the data that actually you shared, especially the percentage, it is concerning and impressive at the same time to see that already 8% basically of the feedback was that the water was fine. So now going back to Basuti and how you've also been talking about tackling. Oh, we have a guest. We have a special guest. Going back to how it is being tackled via space technology. So how would you relate what Anna has just shown today with us, has just shared today with us about the percentage? So is it something that you've also realized throughout your research, and how could possibly this percentage be improved using space technologies?
Yeah, thank you. Looking at her presentation, we have found that most of the job was done like in a manual way, but space science technology can assist in managing those areas like in a digital way and also in a fast way. Looking at the satellite data, you can manage, you can even manage or assess a larger area than a smaller area. Normally satellite data, they provide accurate data better than the manual data collection, because manual data collection is collected by an individual. Sometimes if this individual maybe can be tired or miss a point, then the records can be wrong. So, but using satellite data, because you take what is happening, what is actually happening on the environment, and it can be picked up directly as it is. So if you can miss the point or miss information, you go back to the satellite, to the data, or even to this physical area. So we're looking at the sampling points like underground water, where the underground water challenges can be monitored or managed by the satellite data, like using these sensors like radars that can penetrate deep under the ground to pick the level of water. And also like the wells, satellite data, you can map the well, like the volume of water in the well, and also the data sets for satellites that can also detect the quality of assess or can be used to assess the quality of water. Yeah, thank you.
Thank you, Basuti. So, am I mistaken, or you also have some slides to share before I go on to more engineering questions, let's say, to Miracle, about how the satellites and the monitoring is actually happening from an engineering perspective?
Yeah.
Do you have the slides available?
Yeah. I have
Yeah,
the slides.
okay, good. Let's go with that.
Okay. Yeah, this is the title of the presentation that I would like to share with you. Like satellite data, a key space technology for sustainable water resources monitoring and management in developing countries. So my slides, my presentation will cover the water scarcity issues, the benefits of satellite data mapping and satellite for mapping potential flood areas. So globally, like I've said, water scarcity is a challenge. Like if you look at the United Nations World Water Development Report for 2017, it says 2/3 of water's population currently lives in an area of water scarcity. And also about 500 million people live in areas where the water consumption exceeds the total renewable water resources by a scale factor of 2. But if you look at the map, you see those red areas and the yellowish areas that were areas of water stress, and the blue areas that they plenty, where water is plenty. Looking at Africa, Africa is facing a huge challenge, and even in the Asian area, it's a challenge of water scarcity. So by providing or producing the map like that, so we can easily see where there is a water challenges and what causes those water challenges. Like I've said, the challenges can be, the water can be there but salty, the water can be there but polluted. So what we need is, we need clean water for people and both animals and also for our crops. So as we see, the earth water distribution is like salty water, we have about 97% oceans water, fresh water is only 3%. And also have groundwater, which is like 30%, and ice caps on the northern or cold areas, we see it's like 68%, and the lakes is 87%, swamp 11%, and the rivers, we have only 2%. So this is the distribution of earth water. And the causes of water scarcity, like I've said, it can be climate change. We see nowadays, we see droughts, there's insufficient rainfall in different areas, but other areas, they have more rainfall, but the rainfall can be, the water for more rainfall, water can also be affected by pollution. So the water still, it can be scarcity. It can be scarcity, and find that people can have problem of water because of pollution. So also the rapid population growth, you know, where there are many people, they use water, they also compete with water, with industry, with animals, with agriculture as well. And we see poor water resources management technology. We don't have technologies for monitoring or managing our water resources, more especially in developing countries, because we have a few funds, you know, we have challenges that we are failing to, that leads to us to fail to manage our water resources. And the quality of water, when the qualities of water is affected by many factors, like I've said, it can be land use activities, it can be industries, it can be you know, many things that contribute to that. And the solution is satellite data. So why satellite data or topographic mapping is very important? It is important because you can identify water sources and catchment areas where there's plenty of water even underground. You can also assess surface water quality, like I've said, that you can use satellite data to monitor or to assess the quality of water. It also provides accurate elevation information. Elevation is the slope, because where there is a steeper slope or higher slope, the water engineers, they know exactly where they can maybe put some catchment areas to conserve water, like the dams. So satellite data is very important for that. With satellite data also, you can monitor the volume of water in a dam or any reservoir or reservoir. Also, satellite data can solve transboundary water conflicts, because you find that water is a shared resources. Like you see climate, we rely on natural rainfall. Natural rainfall, there's no border on the atmosphere, so it affects also. That's why I'm saying it can also help, satellite data can help to solve transboundary water issues, because as I've said, the quality of water can be polluted by land use. It can be industries, it can be agriculture, it can be people. So, you know, though we have boundaries per countries, so, but when it comes to pollution, other countries can have more industries, can be, you know, so the satellite data can easily show you what is happening in each area or in each country. So by doing so, countries can work together to monitor the environment so that cannot pollute water. Also, the satellite data can help to identify potential areas of floods. Once you have the appropriate data, you can assess or design models that can show you the potential areas of floods. So this is an example of the satellite data. This is a Google Earth data set for Gaborone Dam in Botswana. So you can see that in 1984, if you compare the image for 1984 and for 2017, you find that 2017, the dam was full. Then in 1984, it was at least a little bit less than the 2017. And this data set was for the same month each year. But if you look at 2015, 2015 is the year that the country has experienced drought. So you can easily see that. So when you present your case to the country or to the nation that they must conserve water, but if you show them exactly what is happening, they will listen, and they will also, they will manage water. Even the government can reserve funds for water management rather than maybe using that money for other things that cannot maybe be of a benefit. So, like I've said, that water is a shared resource. 60% of fresh water comes from river basins and cross national borders, as you can see the report. And also, I gave an example of the Okavango River basin in Botswana. So this is the map of Botswana. As you can see, the northwest of the country, that's where the Okavango Delta is. The west part of Botswana is Namibia, and the north there is Angola and Zambia. So this, the water catchment, like the Okavango Delta, as you can see on the green areas, that's where the area is lower than the brownish areas, the high areas. So you can easily see the catchment. And these rivers, they cut across countries, like from Namibia, Angola, and Zambia. So that's what I said, that this thing, it helps you to identify the transboundary water management system, and it also make countries to work together to develop policies, to work together to manage water so that they provide clean water. And this is the area also in Palapen, Botswana, where it once experienced flash floods. So as you can see, I designed a model to show the potential of flood area from the river, about like 200 meters away from the river, which area can be affected. So the sky blue air light in color, you can see that area the area where the floods can occur. So if you look at the purple color, that's where the settlements are, or the town is. So you can easily see that town date can be affected. So it's better if there was a planning before, they should have moved that town to another area. So by using satellite imagery, it also guides land use planners. So this is another example of the satellite radio, like RadarSat data set that was used in Egypt. So this radar set penetrated like 5 meters deep down, and it also revealed some of the old rivers that was deposited long time ago by the sands. So like I said, satellite data can be very useful for managing and monitoring water resources. So what I can say, I can conclude by saying that satellite topographic mapping is a sustainable tool for monitoring, management, and for planning water resources, water resources, and for decision making, in order for our countries to manage their resources, so that for sustainability. Thank you very much.
Thank you very much, Basuti. It was another very, very good presentation, really giving us an outline of how every of these problems have been tackled so far from different perspectives. And now we are looking at it from a satellite and space perspective. So now, exactly on this point, now I'm going to Miracle. So Miracle is an aerospace engineer, and now he's having his PhD in science instrumentation. So from an engineering perspective, so from the instrument itself, I get many questions to where, how do we actually use the data physically, let's say, from a physics point of view, the data that is coming from the satellite, and also how many of these Earth observations missions are dedicated to this kind of assessments, and how also the institutions in places like Africa or other developing countries, rather than the Western world, are accessing this kind of services.
Thank you, Peter. So yeah, first to answer your first question, how these data can be used physically. Like satellites, they have sensors, so they go around the Earth. So you can imagine that as flying cameras. So satellites, like flying cameras, they go around Earth with a visiting period of a few days or maybe weeks. So they come again and again to the same place. So we can get data about the same place in a time fashion. So if you collect all these data, you have a lot of images basically. But these images, they can be in different wavelengths. So these sensors, they are capable of taking images in different wavelengths. So the reason being, not all the features on Earth can be identified with just one wavelength. For example, the visible wavelength, like what the eyes normally see. But also most of the Earth's radiation out of the, that's coming from the sun, that's reflecting out to space, they're mostly in infrared. So capturing images in all these different infrared wavelengths also give different information. So, and particularly for water management, for water monitoring, these images are arranged in a certain way. So there are so many studies going on. There are so many research saying how these images can be, they can be made into like layers of images. And then you have some index that can say which parts are water, basically. So using these algorithms can help us to decipher these images to identify the water pixels from those images. Yeah, and there are so many free data available right now, publicly available ones. And USGS, that's one organization in US, and there's also there's one called Copernicus in it's a collaboration with ESA. So they have a big pool of data, of Earth observation data, and these are free of charge, and so anyone can use. But the exploitation is very less. Like the data we get is so much that we need so many people to analyze those. So that's the lack of human resources we have. But we have so many information from right from 1980s. So if we want to study about how water has been managed for last few decades, we can do that even with these data. I've been working with these like for past few months, analyzing these data for one of the city where I'm from in India. And there, like I can see how these water systems are changing, how the like it could be based on rainfall, based on the climate changes, the population increase, like basically all the reasons the previous speakers spoke about. So increasing population, increasing food production, and a lot of water needed, but what we get is lower because of the rainfall, or it could be other reasons. So all these trends can be tracked using satellite data. So in a nutshell, you can say like space data can be used for analyzing these situations and also to predict what is going to happen in the future, so that we can be prepared and we can make measures based on that.
Thank you, Miracle. That was a beautiful way of summing everything up. So you hit one of the points where you say we have lots of data which is free to be used, but not so many people able or available to use that data. Which means, for instance, if we are looking exactly at these developing countries and areas, we actually need more specialized people to use the data.
Yeah.
That is a correct assumption.
Yes, that's okay.
Yeah, so you know, as one of the messages is that, which is very important also to share with our audience and anyone also that wants to come and work for space for different missions. So data scientists are extremely important because it's not all about working on the technology, but it's about how we use that technology to help us on Earth. So this is one of the biggest examples. We need more people that are actually able to read those data so that we can give back to our communities. So that's one of the main things. And on this one now, I think we could also start the Q&A session. So if anyone has questions at the moment, drop them in the chat, or you get on your camera and you can ask anything you want to our speakers directly. Anyone that wants to come on the screen?
Actually, I had a question while the participants are typing theirs. I had a question for Anna, if you're still, yes, I can see you, perfect. What you were talking about was pretty much the power of citizen science, because you went and you talked to the citizens, you asked what would be best and what would help them the most, and you collected that data, and there was this sort of circle of knowledge. I was wondering if you could tell us more about that citizen involvement, that consultation of citizens, and then maybe the project that emerged from that.
Thank you, Alisa. The citizen involvement was very, very exciting because first, with that kind of engagement, we were able to know where the questions were coming from. The tool was able to show that Alisa in this location has answered this way. So we were able to map and see where majority of a certain inclination were coming from, and we're able to transmit that to the utility providers in that space, or the water managers in that space. In Uganda, the system is organized in a way that the people who manage piped water are different from those who manage point sources like a single borehole or a shallow well or a valley dam or things like that. We also were able to understand that the population does not know exactly who is in charge of their water. Whenever they face a problem, they actually don't know who to report to. We also understood the way the demograph is. There were more men answering more men have mobile phones, and yet the problem is more of a woman's problem in her home. So we were able to manage how we would do the next publicity engagement in order to find the women. Yeah, and
thank you so much. That was very informative. Thank you so much.
yes, so yeah, thank you. I think then just one more example. We were able also to understand, of course, water is very political in every country, in every society, but we could see from the answers that whenever people have a problem, they first report to the lowest political level in their society and not the water manager. So if we are to solve water problems, it should be very high on the political agenda. Thank you.
Thank you, and thank you very much. That's really, really important to point out as well. We have a question for Miracle from Anna Luisa. So she's asking, as we've been saying that this data is available, where is actually available? So where do people go and get this data from?
So the biggest databases for Earth exploration, Earth observation, there's one called Earth Explorer by USGS. So in my presentation, I've given those links. Also, I have directed to a document where the beginners can learn how to use them, which tools they can use. It can start from either like MATLAB or Python, instead of going to more sophisticated GIS-based softwares. So I've given some basic information for people who wants to get started in these, so they can learn from them. Yeah. Yeah, I think you'll be sharing those presentations with him later on.
Sorry again, do you have a set of slides that you want to share on this one?
Yeah.
Okay.
Yeah, see, so the links are in those presentations.
Okay, you can share your screen, right? You have no
All right.
issues.
Yeah, I can do that. Yes.
And
Yep.
earlier,
So,
Ian sent a message with the link where the three slide of slides are available, so the participants can also go and download them and follow along.
okay. Yeah. So shall I start with my presentation? I already spoke a little bit during those answering those. Yeah. Okay. Okay. So I'm like just wanted to start more, like speak more about the technological side of data collection and how to exploit those. Like I'm doing my PhD right now in space instrumentation, but the reason why I took like got interested in water monitoring was because of these images. Like you can find thousands of these. And Tian, like she said earlier, she's from a developing country, and I was born in a developing country. Now I'm living in a different country, but still, like these things, whenever I visit my place, it goes on. And since I have seen in person, like many of you have seen in person, these kind of situations, I thought like we know space, we have seen the use of space, so we had to do something. Like this information has already been spoken. Like whole world is going on water scarcity. A lot of countries and a lot of urbanized areas, big cities, particularly Africa, they are in very big water scarcity. Mainly because it has the highest growth rate in population, and it's growing so fast, and the urbanization is also getting very severe. So to tackle all these challenges, the local systems that doesn't support. So water monitoring and efficiently using that and repurposing different sources for different purpose, that's the way to go. So, and for monitoring that in a big scale, in a global scale, normal infrastructures don't usually support. That's why we look for space technologies, because it can be used for large sizes. Like Basuti, as she mentioned earlier, like drones can be used, but it can be used for short size, small areas in good resolution. But satellites can be also like used for like for a whole country even, and whole city, for example. Yeah, I already spoke a little bit about this, how remote sensing works. So remote sensing is a field of science where these like that speaks about how like some certain features on a surface can be observed remotely. So in our case, while we want to monitor water, we have sensors in satellites which can take these information. So basically, this works like the sun sends the radiation to the surface of Earth, and it reflects back to space. And some part of that information is from water, and we have to find which part of that is from water. That's what we do while analyzing those data. This is one way of it's one type of remote sensing. So these satellites, they go around the Earth, so they come to the same place again and again after a few days or weeks. So we get information in a periodic basis. But there's also another way of remote sensing. So the first one, which we talked about, where the sun sends in the radiation and the Earth reflects it, it's usually used for optical sensors. So it's cameras which can take images in different wavelengths, invisible wavelengths, which are not IC, and also in infrared wavelengths, which Earth is very sensitive for. Earth sends its radiation mostly in infrared wavelength bands. And using these images, there are so many algorithms available. For example, I have mentioned here as normalized difference water index. So that's a mathematical identification for water pixels in these images which these satellite data collect. And so based on using these algorithms, you can identify which part is water and how much water is there in a particular area. And since we rely on sun in this case, we can only use the images which are without clouds and without darkness, right? But there's also another way of remote sensing, which is called active remote sensing. Here we use radar imaging. So in this case, the radio waves are sent from the satellite, and then it's received back. And this is very advantageous because it can work at night. It can work with clouds sometimes. And also it can go to depths, so it can find the depth of water even. So it's more advantageous, but it's also expensive than the optical systems. But there are so many satellites right now currently working. So it started from 1970s. So we have data repository in these. I will send you the link later. I will show the link later. So we have images collected from 1970s until present day. So if we want to analyze data for last 30 years or 40 years, it's even possible. So that's in remote sensing terms, it's called time sequential modeling or time sequential analysis. So to see how the systems are changing, how the water availability is changing, and how it can go on in the future. And there are so many, like, resolution also gets better by year. So the current ones, they are very good. They have very high resolution compared to the old ones. So in this case, like in old satellites, you can only see water bodies which is bigger, like oceans or rivers or big lakes. But now you can even see small ponds. So that's how the technology has evolved right now. And with the current data, we can tell every information which a normal person who goes to, like, manually goes to every place and can tell. So this reduces a lot of workload, a lot of work for human labors to go to every place and find information. So satellite data can completely revolutionize that part of work style of collecting data and conveying even accurate information. Yeah. So with this information we collect, so we can analyze. So as I said, we have different algorithms to do that. So in both sides on the slides, you can see like how the water has been changing for different seasons. This is the city where I'm from in India. So you can do like analysis like these where the water is changing over the years, and you can even find the cause for that. Like water monitoring using satellite data can be used for several purposes. Like you have listened to a lot of different applications of that, and mainly because our Earth's population is growing. So, and also the urbanization is at a higher rate. So a lot of people in small city, that's getting more and more common now. So drinking water or even agriculture, like agriculture takes the most water, and also drinking water for industries. So water distribution from the same amount of water availability, and planning these is a very big issue. That's why we need these information to solve how, or to find a way how to allocate these resources in an efficient way. And water monitoring can also answer so many other questions, like you can monitor the quality, and also, like particularly in Africa, or most of the equatorial regions where temperature plays a role in evaporation. So you can sense the temperature of the whole region from the satellites, and you can use these to make models about how these water has been evaporating and how you can predict that. So space technology can be supplementary to a lot of ground work, a lot of ground infrastructure to plan the whole city building or water management teams. Yeah. Yeah, this was the main slide I wanted to share to everyone, because I'm a kind of a citizen science. This is not my mainstream. I'm a PhD in space instrumentation, but this happened to be just my passion. And since everything is going on, and like with no answer at the moment, but I saw that space technology can be helpful in finding these answers. So that's why I got involved in, and then wanted to bring everyone in. So citizen science, when like these remote sensing kind of like data analysis and data, being a data scientist, when it becomes like as a part of every citizen, then I think a lot of these data can be used in a proper way. That's why I said, like, we have so much data, but we have very less people who are trained to work on these. So, but it's not a difficult thing to be trained. So there's a lot of data available for free. I have put up the links here. I think you'll be shared with these presentations and the links. And there's also, I have given some information in this toolkit. Like, it's a document where I have some instructions how to use these data and which are the tools you can use for beginners. So it's very in a very basic stage. So you can try to use these, and you can start with, if you like that, you can even start that as a career. So it could be a good career choice as well. And like right now, since like space is commercializing a lot, business opportunities here in this particular area is also growing a lot. It could be either developing systems for observing Earth in with more in a better way. Could be water or any other Earth observation satellites, or it could be using base data for society. How these data can be analyzed and used for the society for making policies and so on. So there are so many businesses that's starting, and there's also a lot of scope for new businesses to be started in this area. There's one example. There's one hackathon that's going to be held in September this year by Copernicus. So they ask for their applications of their satellite data. So they have a huge repository of about 25 petabytes of data. So they want people to use these data and find an application for that. Yeah, I just want to stop with that. If you have any questions, you can write here, or you can also email me. Yeah, thank you so much for having me.
Thank you very much, Miracle. It's a wonderful presentation. I guess there will be so many more things to be said and shared with our audience, that probably there should be a follow-up of this as well, because it's a very interesting and relevant field as well, especially for for new scientists, new researchers. There is a lot that space technology can give back to Earth. So it's also important to demystify, why do we invest into space? This is one of the multiple reasons why we need space, not being independent from our life on Earth. So thank you very much. And now, if we have, we're right on the dot, so now it's 7 p.m. If there are any last questions, or I would just give one moment the word to Anna as well, because she shared with me that she wants to prepare, or she wants to launch a summit that is based on these technologies, and also for the water monitoring. And she wants to gather basically support from other people and other professionals. So Anne, if you want to share with us what is your initiative and how we or anybody else can help you or support this idea that you've had.
Thank you, Bianca. The idea I have is to actually demonstrate the way technology can support water supply and sanitation services, especially in Africa. I also want to use that summit as a way of showing the barriers and how the barriers can be actually can be solved. The uptake for technology in Africa is on a very high level in terms of the mobile phone, and that is the general population. But then in terms of the institutions, the uptake is not as fast. So this summit would actually be mainly focusing on how institutions can quickly uptake technology in different areas, and the subjects would all be revolving around the subject of water and also sanitation. I had thought of some tracks. These include customer engagement, which is citizenry, as Miracle puts it. I had also thought of fintech. I thought of the resource itself, how to manage water as a resource. Especially if you look at land use, there is a rapid land use change in Africa. Because the population is growing very fast and the demand for agricultural land is really increasing rapidly. Then the other area I wanted us to look into was the fact that agriculture is the mainstay for 80% of the population, and yet only 3% of the land is irrigated. So while my main focus is water supply for domestic use, I believe that agriculture, which is the basket, should also be an area of interest. Yes, I want to, now I'm running for support and participation in this technology summit so that we can see how we can organize it.
Thank you, Anne. Thank you very much. And I'm sure that also if you keep linking yourself with all the other ones here and our audience and sharing again this idea, I'm sure that there will be people willing to support your initiative. So it's extremely important that what you are doing and what you want to achieve, and I'm sure that you will get the support that is needed. And now I think we are on the closing. So Ian, I'll leave the word to you.
Thank you everyone for serving, sharing and caring about this much needed global grant challenge. Just to close this show, remember that the greatest global grant challenges are also the greatest opportunities for us to serve, share, care, collaborate, and commit to shared missions and have each other's back. So please do reach out if you need help, if you would like a theme covered in your area, in your country, that serves the women and girls in STEM and space careers. We'd love to hear from you. Please also connect on all socials. We're on all socials. Any concerns? There's so many. There's 35 mentors there with amazing initiatives. It's open for everyone's space now. It's just one message away. So thank you so much, everyone. Love to have a group picture of everyone. If you like to get on camera, we do a screenshot. We will also have a report of this show, which you get sent afterwards. Everyone's ready on gallery view? Hi, Valentina. One more. There you are. Thank you so much, everyone. Have a beautiful weekend. Stay safe, stay healthy, and see you soon. In Series 11, we have a lot of interesting themes coming up. Stay tuned on the Facebook page. Thank you very much, everyone. Bye-bye.
Thank you, everyone.
Thank you, everyone.
Bye.
Bye.
Can I stop the recording, Alicia? Alisa? I actually can do it.